Okay, here we go with Unit 8, Circles, Part 1. The Circles unit is a difficult unit, so you're really going to make sure that you stay up with the notes, ask questions, do your homework, do your practice problems, all that kind of stuff. It's a difficult unit, but it's not impossible. Today we're going to do Day 1. We're going to take a look at the notes 8A on circles, angles, and arcs. So, let's take a look. First we're going to start with the circle itself. There's a lot of vocab here, not a lot, but some vocab here that we need to concern ourselves with. First, we need to understand that a circle is the set of all points equidistant from a given point called the center. That's a definition that you should probably already know. A radius is a line that has one endpoint on the center and the other endpoint on the circle. And a circle can have obviously more than one radius. Then it would be radii. And a diameter. A diameter is a segment that contains the center of the circle. This is probably where sometimes students get confused, is that they forget that the diameter has to contain the center of the circle and has both endpoints on the circle. So just a couple quick examples here. Let's name the center of this circle, and the center of this circle is O. Alright. Name a radius on this circle. There's more than one, like we said earlier, so right now we're just naming one. One of the radii on this circle could be segment OD, but of course, there are others that we could name. OA is a radius, OB and OC are all also radii. And then a diameter. Given our diagram, there's only one diameter that we see, and that is DB. Okay. So far, so good. A central angle is an angle whose vertex is on the center of the circle, or is the center of the circle. There are a lot of different kind of angles that we're going to talk about. Central angle is one of them. This is important. These vocab, that we know that it's an angle whose vertex is the center of the circle, which should make sense. Central, center, they sound alike. So now name the central angles of the circle. So there's more than one. DOA is one. AOB is another. BOC is another. And COD is another. Now, if you said DOC and COB, like the order of those letters doesn't matter. I did use 3 letters because I just don't want to say angle O. I want to be specific as to which angle I'm referring to. The sum of the central angles in a circle is 360 degrees. That should make sense because you've learned for a long time and have known for a long time that circles have 360 total degrees in them. Central angles are equal to the arc that they cut off. Okay, so the angle, when the vertex is on the center, when it's a central angle, when the vertex is on the center, the angle equals the arc. So if we take a look at this problem right here, we want to know DOA, AOB, and BOC. Well, AOB is probably the easiest. That arc is given to us. That arc is 42 degrees. So angle AOB is also 42 degrees. Okay. Then we have to use some information, things that we know, to figure out the other angles. If this is 360 degrees, the diameter cuts it in half. So this whole half right here is 180. Well, 180 minus 42 is 138. So this arc is 138 right here, which means that this angle is 138 degrees. So that's the measure of DOA. And then BOC, same logic here. This is 136, so all that's left here is 44. So that's 44 degrees. And those are our 3 angles there. Alright, let's take a look here. Just some more vocab. A semicircle is half of a circle, so 180 degrees. A minor arc is an arc that measures less than 180. And a major arc is an arc that measures more than 180, but obviously less than 360, so it stays in the circle. So let's name a semicircle here. So a semicircle here would be, we want to name it an arc, and we want to use, sometimes you can get away with 2 letters, but for a semicircle we're going to name it with 3, so you know which direction to go. So DAB is the semicircle that I'm going to name. A minor arc is an arc that is less than 180 degrees. I can prove that arc AB, that's less than 180 degrees, so AB There are others, obviously. BC is a minor arc. AD is a minor arc. And DC is a minor arc. So any of those will work. Those are all minor arcs. And then a major arc. Again, here I'm going to use 3 letters for the major arc so you know which direction I want to go. So if I want to start at B and I want to name a major arc, I could say B, C, and then all the way around to A. So BCA would be a major arc. I could also say that, I could have said BDA, that's fine too. Or you could say DCA, that's another major arc, DCA. So, the order that you put the letters is going to dictate the order that you go in around the circle. The arc addition postulate. So we've done the angle addition postulate, we've done the segment addition postulate, and now the arc addition postulate. And it's basically the same concept, is that if we're looking at the measure of arc ABC from here to here, if we're going to start here and look at this arc all the way around to here, that it's equal to this arc here plus this arc here. Pretty simple concept. So let's take a look at this circle down here and see if we can't figure out these missing angle lengths. Easy now. See if we can figure out these missing angle lengths based on the information that's given. So this is 70, this is 46. Let me take you way back to the beginning of the year. I know that this is 70 degrees right here because these are vertical angles. I also know that this semicircle is 180 degrees. Well, 116 of those degrees have already been used up. So this is 64. And then same logic here. If this is 70, then I have a total of 110 degrees left there. So I've labeled the circle. Now it's much easier for me to go into the problem and just start writing down my answers based on what I have. So COD, that's 64. EOD, that's 70. AOD, that's the semicircle, right? So that's 180. Now these 3 questions ask for angles, and then these 4, 5 are going to ask for arcs, but the angles and the arcs are the same when it's a central angle, so I'm not going to do anything different. Arc CD is the same as measure of the angle AOD, so that's 64 again. DE from here to here is 70. EA from here to here is 110. ABC, so ABC, so this arc is equal to the sum of these 2 angles, that's 116. And ADC, so A to D to C, so A to D is 180 plus 64 more, 244. Alright, let's take a look at these. So we're going to assume that the bold dot is the center of the circle. The reason that that's in the directions is so that you know when you're working with a diameter and a radius and when you're not. The rules change if it's not a diameter or radius. But here it is. The reason that helps us is this is 63 and that's 57. You add those together and you get 120, which means all that's left for this is 60. These are vertical angles again, so that's 60, and then all that's left there is 120. So it wants to know the measure of arc dB. I wasn't asked some of this stuff, but I think practicing labeling our circles with the information that we can figure out is a really useful tool. The measure of arc dB is this arc right here, which is going to be the sum of these 2 angles. So the measure of arc dB is 117 degrees. Then these are some examples of the kind of problems you'll see. We want to solve for x. You have to be able to figure stuff out. One of the reasons this unit is difficult is that you got to figure stuff out. The whole thing is 180 because it's half a circle. From here to here is a semicircle. So these 2 add up to 115, which means all that's left for over here is 65, which that's what I'm going to set that angle to. 65 equals 8x minus 7. Again, I got that 65 from 180 minus 71 minus 44. Okay. Then I'm going to add 7 to both sides. I get 72 equals 8x, so x equals 9. Done. Easy peasy. And there's at least a dozen of you that just said lemon squeezy, and probably 3 or 4 that said of you like this, lemon squeezy, with an accent that doesn't make any sense. Alright, let's take a look here. Here I'm given two arcs and I'm given two angles. Fortunately for me, I see the center of the circle and know that if that's 150 degrees, then so is that. And if that's 50, so is that. So I'm simply going to add these four up and set them equal to 360 because this is a circle. So 360 plus, I'm going to add those from the beginning, 200, save myself a little work, plus x plus 96 minus 12x minus 2. Go ahead and pause the video here and take a second and see if you can't do some of that algebra on your own and get to the answer. Alright, so I'll walk you through it if you didn't do it on your own. 360 equals 294 minus 11x. Negative 11x equals 66. X equals negative 6. Now some people are going to ask, well, can we have a negative x? Sure, you can have a negative x. You can't have a negative arc or negative angle. But if I put negative 6 in here, I get that's 90. And if I put negative 6 in here, I get that that's 70. So I'm good to go. Here on number 5, if that's 45, then that's 45. And these are vertical angles, so they're congruent. So 45 equals 6x plus 3, and x equals 7. So far, so good. Let's take a look at inscribed angles. An inscribed angle is an angle whose vertex is on the circle. So we did central angles. That was when the vertex is on the center. Inscribed is when the vertex is on the circle. Okay, this right here, this angle, the vertex is right there on the circle. An inscribed angle equals half of the measure of the intercepted arc, or 2 times the angle equals the arc. It depends on what you're given. Let's walk through some of these example problems and I'll show you what I mean. On this one right here, it's an inscribed angle. The arc is 100, so the angle is 50. Alright. Let's take a look at this one. The angle is 24. So if we have the angle, 2 times the angle is the arc, so B is 48. Here we have two angles that are given, A and B. And these problems look like they can be difficult sometimes, but if we take a look, this angle A intercepts this arc right here. Angle B intercepts the same exact arc. So A and B are going to be the same value. So A and B both equal half of that arc, so 24. Here, I like this problem, this one over here on the right. It's got a lot to it, and yet it's pretty simple at the same time. 60, if I extend these a little bit and take a look that this is an inscribed angle, 60, the angle is half the arc, so Y is 120. 75, the angle is half the arc, so X is 150. Now, I have a circle. A circle is 360 degrees. Well, I've used up 150 here and 120 there, so that's a grand total of 270. So Z must equal 90, because that's all that's left. You could also figure out that this angle in here is 45 because of what you know about a triangle, and then double it and get 90. Over here for angle X, the arc that it is inscribed in is a semicircle. Well, semicircle is 180, so X equals 90. Here, even though this is an odd-looking inscribed angle, but it's still just an inscribed angle. It's an angle whose vertex is on the circle. So the angle is half the arc, so X equals 100. Here we have, let's see, 60 is here, so A equals 120. B, well, if this is 120 and this is 100, that's 220. So all that's left for B is 140 because of the circle being 360 degrees. And then C is going to be half that. C is 70. Here, if this is 55, well, that's a central angle, so X equals 55. Y is an inscribed angle, so it's half of that. Half of 55 is 27.5. And that's how you find those problems, or the answers to those problems. Those problems found you. So here we go. Here's a few more. On this problem, we have 111 degrees right here, 151 right here. That adds up to 262. So all that's left for this spot right here is 98 degrees. At this point we have this angle. If we double this angle, we get this arc. So let's double that. 26 plus 8x equals 98. So 8x equals 72. So x equals 9. Let's take a look at number 8. We have 32 equals 9x plus 10. You know, sometimes drawing these out with a straight line helps us sort of see what we're talking about. So here's this angle, 32 degrees, and it intercepts this arc right here. Yikes. So that arc right there. So if we double 9x, if we double 32, we get 64, and that equals 9x plus 10. So 9x equals 54, and x equals 6. Down here, similar problem except for a little bit different. Okay, we have this angle, so this arc is double that. That's 6x plus 22. At that point, we're just going to add up all three arcs and set them equal to 360. So we have 8x plus 6x plus 9x. So that's 14 plus 9 is 23x. Then 16 plus 22 is 38. Plus 23 is 61. And then we have 23x equals, that handwriting is really bad. We have 23x equals 299, and that is x equals 13. Now, the other thing that we have to do here is we have to find make sure we're answering the question. The question says find WVX. Okay, so we're going to take, that's this angle. So 3 times 13 is 39, plus 11 is 50. So the measure of angle WVX is 50. Last thing, theorem, the opposite angles of a quadrilateral in a circle are supplementary. So what you're able to do is just, and remember, we have to remember supplementary means they add up to 180. So on this problem, really simply, 180 minus 108 is A, and B is 180 minus 125. That's it. That's all you got to do. Find the missing arc. These sometimes are tough for students. You know, they want to know the arc LR. To do that, you're going to have to find things that you don't need. That's the easiest way to describe it. I know that if this is 104, that this whole arc right here is 208. I know that if this is 105, this is 75, and that lets me know that this whole arc here is 150. I still don't, I need this arc right here, so I have to find a way to figure out what that piece is. If I can figure out what this angle is right here, that should tell me this is 76. Okay, if this is 76, that means this whole arc here is double that, so that's 152. Okay, so L to Q, LPQ is 152. If I look at that and then see all the other information I have, finding the missing information is the hard part on these problems. So what you have to look at is, we have this whole arc here is 150. We have this whole arc here is 152. Well, this part of it is 64. Okay, so real quick on your calculator, 152 minus 64 leaves us with 88. So this particular part right here is 88. If the whole thing, let's get rid of that. If the whole thing is 150 and this part's 88, how much is left for this part right here? And the answer to that is 62. Now, I think that is a hard problem, and there's the hard part about some of these problems is that you're going to have to find information that you weren't asked to find, and you have to work and figure it out. But all you're doing is using the facts that we've learned. Here, we just said that opposite angles in a quadrilateral inscribed in a circle are supplementary, so I can really just add these two together, set them equal to 180. I get 14x equals 154, so x equals 11. That's it for the notes. Hope you enjoyed. You can take a look at 8B if you're watching this for another teacher. If you're watching this for me, we're going to do 8B together in class. Have fun, stay safe, and don't watch Godfather 3. It was terrible.